Cream Dog did not play. I wish he would. Mr. Keller played. Mr. Bourne plays. The study hall guy down in 127, he plays. Miss Cook played. Normally Mr. Wolfer plays, he did not. Turns plays sometimes. Miss Kessler played this morning. Miss Bogdansky plays. Mr. Sweet, the gym teacher, he plays. He's actually pretty good. Alright, here we go. We're off track, gotta get back on track. So, let's see, I just looked at what we didn't do yesterday. So, problem number 1, we're doing application problems today, guys. Please listen for 2 seconds. Yes, I know some of these application problems are very far-fetched, right? We're going to be dealing with, we're measuring the length and width of a pool or something like that, or rectangles in rational expressions. Are you ever going to do that in your real life? No. No, but it helps us do extra problems and helps us do different thinking of problems, okay? So that's why I do it, so please play along. You will survive. You'll never have to measure your pool or rectangle in rational expressions, I promise. But in some of these problems we might. So our first problem today, Jordan came up with the following as his final answer. He would have gotten it marked wrong because he did not simplify. Would you please simplify it completely for Jordan? Alright, so let's do this for Jordan. If I want to simplify this, what should be my first step before I can simplify? Factor. So I'm going to start by trying to factor out GCF in top and bottom. In that numerator here, can I factor out a certain number from every piece? 5. 5, good. So 5 times x squared plus 3x minus 10 over. Hey, I'm going to rewrite this below it. I like having my x squared term first. Just something that I like. It's just personal preference. You don't have to. Is there a number I can take out of that denominator as a GCF? -2. -2. Good. We want to get an x squared as positive. So take a -2 out, becomes x squared minus 25. Alright, am I done factoring? No. Factor each of those pieces. That x squared plus 3x minus 10 and x squared minus 25. On top it factors to x plus 5, x minus 2. In the denominator, hey, what is x squared minus 25? What do we call that? Difference of perfect squares. Very good. So that becomes x plus 5, x minus 5. Because we can just take the square root of both pieces, right, add them and subtract them. Alright, am I all factored now? Yes. Okay. Now I can start simplifying. Right? What do I have that I can simplify?
X plus 5.
X plus 5. Good. Anything else that I can simplify?
No.
Are you sure? Like I have a -2 and a -2.
No.
No, right? We can't do that. Bless you. X minus 2 is in one term. We can't take it away. So, rewrite it 5 times x minus 2 over -2 times x minus 5. Is that a viable answer? Is that a good answer on a test?
Yes.
Yes, that is okay. Now, do you have to leave it like that?
No.
No, you can distribute it. I prefer if you distribute it. I prefer to distribute it myself, but you do not have to. Alright? So 5x minus 10 over -2x plus 10. And that's our final answer. That one wasn't so bad, was it? Ish? Okay. Good. Good talk. What's that? The adding and subtracting ones. We'll do a couple of those today, I think. Alright. The next two problems, remember the area of a triangle is length times width. So we're going to measure a pool in rational expressions here. You'll survive. Alright, Sally has a rectangular swimming pool. It has a length of 4x plus 32 over 5x squared and a width of 15 over x plus 8. Find the area in simplest form of Sally's pool. So finding area we said was what? How do we find area again? Length times width. We're going to multiply the two together, right? 4x plus 32 over 5x squared times 15 over x plus 8. When I multiply, Abby, what should my first step be? Not simplify. Such with an F. Factor. Factor first. So if I look here, I can factor GCF out over here. 4 times x plus 8 over 5x squared times 15 over x plus 8. I can only factor that one piece. That's it. Well, now, Natalie, what am I going to do? Simplify. X plus 8, top and bottom. What else? Angie. 5 and the 15. I can take a 5 out of both. Anything else? No. So I'll multiply. 4 times 3 gives me 12 over just x squared left in my denominator. So her pool's area is 12 over x squared.
Wow.
Nice.
We're going to be given units, so we have to like put.
If you don't put units, I'm not that worried about it. You can do the math, we're good. Cool? Because you're never going to measure pool and rational expressions. So.
I mean,
We just did, but okay. Any questions before I keep going? Cool. Shirley has a rectangular garden. It has an area. Ooh, area of 6x squared y to the 4th divided by 3, a to the 4th, b to the 5th, and a width that is 15xy to the 5th over 18a to the 6th, b squared. What is the length in simplest form? Oh, well, I know how to find area, but I don't know how to find length. What? Divide them. So do this one divided by that one? No, right? Area equals length times width, which means I'm going to divide the area by the width to get my length. Right? So my area is 6x squared y to the 4th over 3 a to the 4th b to the 5th. Divided by my width, 15 x y to the 5th over 18 a to the 6th b squared. That's a 6. A to the 6th. Alright. AJ, do I divide by fractions?
No, you have to put the denominator. You have to put the numerator and denominator.
Of which fraction?
Oh, the second one.
The second one. Good. We multiply by their reciprocal. Very good. So 6x squared y to the 4th over 3a to the 4th b to the 5th times, right? Keep, change, flip. We're multiplied by the reciprocal. 18 a to the 6th b squared over 15x y to the 5th. Alright, I've changed to multiplication. We said when we multiply, our first step should always be to factor. Can I factor anything? Remember, factor, not simplify. No, so I can start simplifying right away. Well, what is something that I might be able to simplify here?
18.
What's that?
18 and 3.
18 and 3. What can I take out of both?
3.
3. I'm left with 1. I'm left with 6. Good. Anything else?
A4 and A6.
What's that?
A4 and A6. A to the 4th.
A to the 4th. I can take 4 out of there. A to the 6th. I'm left with a squared. Okay? Anyone see anything else? What do you got, Natalie?
6 and 15.
6 and 15. I can take a 3 out of both. 2, 5. Good. Anything else? X and x squared. I can take an x out of both. On top I'm left with x. On bottom it cancels out. Okay? 2 more things. Y to the 5th, y to the 4th. I can take 4 of them out. Top they cancel. Bottom I'm left with just 1 y, or y to the 1st. Okay? One last thing. Sid, what do you got? B's, I can take 2 out of both, right? B squared cancels. B to the 5th turns into B to the 3rd. Alright. I've simplified everything. So I'm going to multiply across the top. 2x times 6a squared gives me 12. A squared x over. Hey, does it matter what order you put your variables? No, I don't care. Right? 1b cubed times 5y. So 5b cubed y. Okay, one last check. Can I simplify anything else? No. That's it. Hold on. Alright, we've done 3 problems so far. How are we feeling?
Great.
Great. Hey, how about this? Let's skip number 4, and if we have time, we'll come back to it. So the next 2 are the addition and subtraction problems. I want to do those first. Cool? Is that okay with everybody?
Yes.
Okay. So let's go to 5 right away. Segment A is 6x squared plus 8x over x squared minus 25. Segment B is 5x squared plus 2x minus 5 over x squared minus 25. How much longer is segment A than segment B? Well, what should I try and do?
Subtract.
Subtract. I gave you that hint. So I'm going to take segment A. 6x squared plus 8x over x squared minus 25. And subtract segment B. 5x squared plus 2x minus 5 over x squared minus 25. Okay. When I subtract, I must have common denominators. Do I have that?
Yes.
Yes, so I can go ahead and I can subtract right away. Remember, guys, like I said, this is one of the biggest mistakes made on the test. That subtraction goes to all 3 of the pieces here. Alright? So if I go across top, 6x squared minus 5x squared.
X squared.
Gives me just x squared, or 1x squared. 8x minus 2x.
6.
Gives me 6x. Technically 0 minus negative 5. Gives me a positive 5. And that subtraction goes to the negative and turns it positive. That's a 5. Plus 5. Over x squared minus 25. Right, our common denominator stays the same. Alright, cool. Done? Box it up?
No.
No. What do I have to do, Miss Larson?
Factor.
Factor, because I have to try and simplify it. My numerator factors. X plus 1, x plus 5. My denominator is one of those cool things called a difference of perfect squares. Gives me x plus 5, x minus 5. Alright. Can I simplify? Faith, what can I simplify? X plus 5, good. One of my denominator, one of my numerator. I'm left with x plus 1 over x minus 5. That's my final answer. Yes,
I
ma'am?
thought you couldn't do that if it was like subtraction or division, like cross them off.
So we can cross them off as long as I have the whole term there. Right? Because I technically have multiplication between these.
Okay.
So if I have multiplication, I take the whole term, then I can take it away. Does that make sense?
Okay.
Right? Just like simply, Kylie,
Yeah.
it'd be just like simplifying 6x over 2y. Right? I can still cross these off,
Okay.
right? Just like here. I have 2 terms on top, I have 2 terms on top.
Okay.
Okay? Alright, so that was the easy addition subtraction problem, right?
Easy.
The next one's not going to be so easy.
Oh.
Okay? Are we ready for it, you think?
Yeah.
Yeah, alright, let's do it. Number 6. The statue of Mr. Siebert is negative 3x over x squared minus x minus 6 tall, and the building that it stands on is 2 over x squared plus 4x plus 4 tall. How tall are they together? We can add them, right, and figure it out. Right, 'cause I know you all measure your statues in rational expressions. So negative 3x over x squared minus x minus 6 plus 2 over x squared plus 4x plus 4. Alright. When I add and subtract, I need to have common denominators. Do I have that? No, so I'm going to factor them to see what pieces do I have here. The first one multiplies to negative 6, adds to negative 1. What's it going to factor to?
X minus 3, x plus 2.
Good. X minus 3, x plus 2. The second one multiplies to 4, adds to 4.
X plus 2,
X plus 2 x plus 2. Alright. So let's figure out our least common denominator. Do they share any factors? Any terms? X plus 2, very good. Okay? So I'm going to cross them off. This does not mean they're going away. That just means I use them when I found my least common denominator, okay? Do they share any other terms? No. So I'm going to take everything else that I've left over that I've not used yet and multiply it into my least common denominator. So x minus 3. So now I've used that one. And x plus 2. Like I said, it doesn't mean they're going away. I'm just using them to make my least common denominator. Okay. Does that make sense how we found that part? The least common denominator. We took what they shared and multiplied by everything else that was left. Now what I'm going to do is I'm going to take negative 3x over x plus 2, x minus 3. And I'm going to take 2 over x plus 2, x plus 2. And I need to multiply them by something to make them the least common denominator. The first one, the first fraction I have. What am I missing for my least common denominator? X plus 2. So that's what I'm going to multiply on top and bottom. The second fraction, what am I missing? X minus 3. So I'm going to multiply that. Top and bottom. Alright. Remember, we are not dealing with those denominators right now. We're leaving them as 3 pieces. On the top, however, we're going to distribute into these parentheses. So I should get negative 3x squared minus 6x over my denominator plus 2x minus 6, same thing, over my denominator. Okay, do I have common denominators now? Yes. Did I lose anyone on that step? We all follow me so far? Okay, so now that I have common denominators, now I'm going to add across the numerators. Negative 3x squared plus, there's no like term over there, so it stays negative 3x squared. Negative 6x plus 2x. It's a negative 4x. 0 plus negative 6 just stays negative 6. And that is over that common denominator. Alright. At this point we should be trying to do what? Factor so we can simplify. Now I'm going to save you the time. It does not factor. Alright? So do I need to try and FOIL out that denominator, multiply all that? No, just leave it as it is. This is your final answer then. Do not just assume, however, on a test that it won't factor. Alright? There will be some that might factor, there will be some that might not factor. Try to factor it. Right? However you do it, box method, grouping, guess and check. If it doesn't factor, and that's your answer. How was that addition problem?
Good.
Was that okay?
Yeah.
Okay. Do we want to go back and do number 4? No? Alright, I'll just handle the homework then. Okay? Cool. Hey guys.